Visual effects artists James Schwalm and Ian Hunter are going to be joining us now. Both won Best Achievement in Visual Effects Oscars and Outstanding Supporting Visual Effects in a Photoreal Feature Visual Effects Society Awards for their innovative techniques used to give a unique photorealistic look to the biopic First Man in 2017. Ian Hunter is a decorated visual effects supervisor and co-founder of New Deal Studios, Inc., and he has won 2 Academy Awards for Best Visual Effects for the 2014 film Interstellar and at the 87th Academy Awards in 2015. So congratulations. And in addition to being part of the special effects crew for The First Man, James Schwalm is known for his work on Transformers, Dark of the Moon 2011, Transformers Revenge of the Fallen in 2009, and Transformers the original in 2007. So we're so happy to have you with us today. And
Thank you.
Take it away.
Thanks.
Give him a round of applause.
Thank you. Hello, I'm J.D. Schwalm. Myself, Ian, Paul Lambert, and Tristan Miles all won an Academy Award on the movie First Man. Ian, Paul, and Tristan, like all of you, are a lot smarter than me, so bear with me while I try and get through this. One of the first things we did in this film, and one of the projects that I had the most fun working on, was the multi-axis trainer, and that was the device that NASA developed to train the astronauts to fly the aircraft in a non-atmospheric environment with no wind. So the astronauts had to overcome the constant roll and spin that the aircrafts could get put into in outer space. This machine was built by NASA engineers in the 50s and 60s, and it gave the pilot a joystick that controlled roll, pitch, and yaw, and they could pull themselves out of a spin while in outer space. Our director, Damien Chazelle, was very adamant about putting this in the film, and he tasked us with building this device. There isn't one in the world anywhere. All the old ones are gone. And we had nothing to work with. There was no blueprints, there was no images, nothing. It was all a bunch of YouTube and Google searches. And I spoke a little fast because there's some NASA footage that'll show up, which is what we found on the internet. And that's all we had to design off of. Our production designer kind of looked at me and said, make it look like that. So that's the real one. We have no idea what made it spin, how it worked, and what propelled it, but we had a general idea of what it did. For our design, we knew that we were going to have 3 axes spinning amongst each other like a big gyroscope, and I chose early on to control it with electronic servo motors and a motion control system so that we could stabilize each axis and bring it to a point where the actors could safely load and unload from the machine while we were filming. We start with our design in a program called SolidWorks, and this is our 3D model. You can see our 480 volt servo motors on either side. There's 2 on each axis. They're there, and try and get the pointer going. There's another one there and up there, which are not in this drawing. All the servo motors, everything was spinning constantly, so all the wires would have gotten wound up, so we ran everything through slip rings or commutators, 480 volt power, and 2-wire digital communication, which we used a CAN bus for to control all the servo motors. The other challenge to this bad boy was we had to fit the whole machine through a door about as big as the one you guys have here under the exit sign. So everything had to bolt together and come apart, including this big steel C-shaped frame that took everything. We designed the whole thing in SolidWorks, and everything gets outputted from SolidWorks into a tool path for my CNC machines at my shop back in Atlanta. Most of this stuff was cut on a CNC 5-axis water jet, and the tubing was all done on a CNC plasma cutter with a rotary table. One of these is a video. There we go. This is our first day of testing, and you can see the intricacy of all 3 of the axes spinning amongst each other. So, and we had to put every single actor in the scene in that device. Stunt guy turned purple. He was in it the longest. The actors only were in it for about a minute or two at a time, and they actually did fine. The next thing we did on First Man, which I think was the biggest technological achievement, was we took my motion platforms, which is this, this device here. And these are basically a 6-axis, we call them a gimbal motion platform. It's, they're used in the outside industry as flight simulators or military flight training. You put your aircraft on top of it, and they have all movements of motion. We took this device, took the output signals from all of the cylinders in the real world, and we're able to input it into the LED wall and control the video playback in real time. This is us just tuning the machines to give you guys an idea of how they work. Over here you can see I have a miniature model of the device, and everything you do with the miniature, it does on the big one in real time. This is our LED wall. It was 180 feet by 40 feet tall. You guys would know the playback terminology it uses a lot better than I do, but it was 4K, super high def. Ian will explain the rest. And what we did is we took plate shots of the environments that the scenes were going to be filmed in with a 360-degree array camera. They flew helicopters and jets with this camera rig on it through Pasadena, where Edwards Air Force Base is across the desert. And we put those images on the LED wall, and the director would choose the frame at which he wanted to have on it, and the rest of the environment, from the array, was in the background, and wherever the motion base was pointed, that's the image we were looking at. And in order to get 90-degree rolls and things like that, we were able to have the motion base control the video, so it would counter. So as the motion base would go down, the video would go up. As the motion base would go left, the video would go right. And it gave much bigger field of view. And this is all done real time. The camera is shooting directly into the LED wall for all these scenes. Everything you see here is practical. There's no post-visual effects work done. This is all shot right into the LED wall. You can see the shake from the gimbal, everything right here. This is my favorite video. It kind of gives you an idea of the machine controlling the video playback. This was a shot where we wanted the horizon to tilt more than the gimbal could do. The motion control program that we use is the same one that we used on the multi-axis trainer, which is Concept Overdrive. It's built by Steve Rosenbluth. He's actually local out here in Burbank, California. This is us trying to calibrate all of the glitches and shakes that we encountered the first couple days when we turned it on. The encoders for the motion base are analog, so they have a 0 to 10 volt signal, and it didn't compute well with the high resolution video. It would shake a ton, so we had to put a bunch of filters in there to smooth everything out. This is my favorite shot in the movie. This is in the opening, and I think this is what really sold the LED wall. All the reflections on the helmet were done in camera, and the part that I noticed the most was the reflection on his eyeballs in this shot that I don't think we would have been able to get in a post-visual effects world. This is the one where occasionally I get to blow things up for a living, and we got to do it here. This is the LLTV, Lunar Landing Training Vehicle. We built this device based off photographs, just like we did the multi-axis trainer. Built a steel frame at my shop in Atlanta. Big giant pick points to hang it from a crane. And the crane operators, the company Southway Crane, they actually allowed us to control the computer system that controls the crane through our motion control system, Concept Overdrive. So all the crane movement was controlled by us. The stuntman was controlled by us on his winch. And all this was done seamlessly in a one-take in-camera shot, the whole scene right here. You get the ejection, you get the crash landing, and all practical effects. Obviously, they had to remove the crane and the wires and things like that. But here's us fabricating the LLTV in our shop. And we created all of the thrusters, 3D printed all the cold gas thrusters, high pressure solenoids and CO2 gas to create the thrusters to try and balance the machine while it flew through the air. And of course, we did the old hanging the guys from wires to simulate zero gravity. One of the neater things we did on this film was we learned early on, we started playing with helium, and we were using helium balloons to float lightweight objects, pens, the Walkman, you know, that classic scene with the Walkman spinning, the helmets, flight books. We would run small wires out the lid of the spacecraft, and they'd be attached to helium balloons so the actors could interact with them, and we'd make all the objects just essentially buoyant in the air. I'll give it to Ian. Thank you very much.
Well, my name's Ian Hunter. I'm the other supervisor, one of the 4 supervisors on First Man. And JD was in charge of all the full-size practical effects, as you saw with the gimbal and the full-size capsules. Our overall visual effects supervisor is named Paul Lambert, and he was in charge of sort of putting it all together in terms of figuring out how to use the LED wall to do everything in camera as much as possible. Also, a lot of the footage that we found from NASA, actually found 70mm footage that we could then use to do some of the launch scenes. I don't have any of those to show you, but the one thing about them was it was an older military format camera, so it was a square aspect ratio, and we were a 2:40 movie, so there was nothing left and right. So even though we started with some practical 70mm footage, everything on the left and right of those images for the launch had to be digitally created. So the one thing that was happening that JD and I both had to deal with was our director, Damien Chazelle, really wanted this movie to feel hyper-realistic. He wanted us to feel like we were there with the astronauts and going on their journey. So we never did any sort of, I would say, God's eye point of view shots. We always tried to get the camera where a camera operator could put it, either inside the capsule or strapped to the outside. And as much as we could use the LED screen and the full-size capsules, that's what we tried to do. But there were instances where we needed to get some shots, let's call them medium shots of the spacecraft, and in that case we resorted to using miniatures. So the definition of a miniature is it's not full size. I'll leave it at that, but I'll show you some demonstrations of how big the models were. So this is a video showing some of the work we did in miniature. This is the Saturn V rocket for before it launches, when it's actually leaving the vehicle assembly building. And that was shot, and then it's my favorite shot actually, just the Saturn V against the sun. This is the shot of the Apollo capsule leaving the third stage Saturn rocket, and it turns around and then hooks up and takes out the lunar module. And there's the lunar module, again shot on stage, and then composited in over the moon surface. So miniature effects. Whenever we could, we shot full size. Then we resorted to using miniatures for medium shots. We used miniatures primarily for shots of the Saturn V leaving the vehicle assembly building as it's on its way to the launch pad. We used the miniatures for the shot of the Saturn first stage and second stage separating, the sort of classic shot of the ring falling away as the two rocket nozzles are in the foreground. And then we used miniatures for what we call the ballet sequence, which was the Apollo module pulling out of the third stage of the Saturn rocket, turning around, coming back and hooking up to the lunar module and pulling it away from the third stage, and then finally flying on their way towards the moon. So let's start with the Saturn V. It was used for wide shots. It was built at 1/30th scale, but it's a huge rocket, so even at 30th scale, the miniature of the Saturn V ended up being about 11 feet tall, and with the gantry, about 14 feet overall. What we had to do was come up with a method of doing this work, and the other thing is we had to do it in Atlanta, Georgia, where there's not a lot of model makers. So what we came up with was a technique where we made basically giant model kits. So if you're familiar with building Revell or Airfix model kits, you're sort of familiar with that approach, which is you got all these parts and they all fit together. So fortunately, we had a room full of 3D printers, and we started with a digital model of each spaceship. We divided those digital models into components, and then we 3D printed parts that made sense to be 3D printed, laser cut, or sometimes just use PVC pipe. So in the case of the Saturn V, the main body is PVC pipe of the correct size. The engine shrouds, engine nozzles, et cetera, are all 3D printed details. And then the skin is either laser cut or vacuum formed plastic pieces that are added to it. And one of the things we wanted to do was to make sure that even though we're using these modern techniques, 3D printing, laser cutting, CNC cutting, to make the models back then in the 60s were built by hand, essentially. You know, these were one-offs that were going to be discarded, used once. And so we wanted to get that sort of handmade feel to them. So even though we started with these high-tech techniques, we would always apply pieces of aluminum foil, or we distress the surface somehow to get it to have a handmade feel, so that when you're close up to them, it didn't feel like something that was made in this century. It was something that was made back in the 60s. You'll notice on the right-hand side, here's the rocket outdoors, and there's some black duvetine around it. So for the shot of it exiting the vehicle assembly building, we photographed the vehicle assembly building first with the camera tilting up and looking at the sky out the doors. There's no rocket there. In order to put the rocket in, we photographed it later in Los Angeles and shot it outdoors again for that natural sunlight, can't beat that. And then we put the duvetine around it, and it was on a frame being held up by a gradall. So on cue, we could retract that gradall and the sun would appear, and it appeared that the rocket itself was exiting the building when in fact it was stationary all the time. Again, one of my favorite shots, only because we needed to put something in the trailer that they didn't have to add anything to, so it had to be completely in camera. So in this case, we positioned the rocket outdoors again, and my DP, Tim Angulo, waited till about 4:30 in the afternoon when the sun was gonna be in the right place, and because we shot with motion control, we could do just the slightest dolly move and let that sunlight appear through the crack between the gantry and the rocket itself, and get the shot. And of course, they put it in the movie because it's a beautiful shot. We also shot several shots of the Saturn indoors. This is again supposed to be outside, but we were shooting in Atlanta in the winter, so we didn't really have Florida weather. So we put a blue cyc up and shot it with lighting on the stage. This was supposed to be a very early morning shot, so we've got a lot of uplighting on it. We've also installed LED lights in the gantry itself, and that gave it a sense of scale. Though all those work lights are very small individual work lights in there. There's hundreds of them in there. And in this image, you can see the rocket in the background, and then on the monitor on the left, you can see our composition. And we shot this many different exposures. Eventually, Damien chose one that was almost a silhouette, almost a navy blue background with a black rocket against it. He wanted sort of an ominous feel. He didn't want these guys to feel very cheerful or happy that they're going to be launching to the moon. They wanted it to feel a bit scary. So we went for that look. Once we were done with the Saturn, we moved on to the scene with the classic ring shot of the transition ring between the first and second stages coming apart. So the Saturn rocket was 1/30th scale, much smaller scale. A person's about this big. For all of the rest of the models, we went up to 1/6 scale, which is 2 inches to the foot, so a person would be about that tall. Well, a normal person this tall, Buzz Aldrin about that tall. And, and for that, we built the transition ring, which you can see on the left. That was aluminum rings being suspended apart, and then a lot of plastic and laser cut pieces on that. That man is not quite that strong. There's actually a rope holding it up, but you get the idea. And then on the right, we've got the rocket nozzle for the second stage. And again, it's a combination of plywood rings, but then 3D printed nozzles and laser cut panels that were all added, and then a lot of hand applied tubing and wiring to get the detail. And the trick here was that the second stage nozzles were all locked off. The camera was locked off to that. But the ring itself was mounted on a model mover. So that L-shaped black clad device you see next to the man, that was a model mover that had a roll, pitch, and yaw axis on it, and we could mount the models to that. And then it was on a dolly, so we could have it dolly away from us. And so for this shot, we first shot it in our beauty light and used the ring to actually block off our key light to block out the nozzles. And then on cue, we could get that ring to fall away and reveal the light on the nozzles, and the ring would go down the stage and spin and do all its action. But because we were shooting motion control, once we had our beauty pass, we would bring the ring back into place, turn all the lights off, and then JD's crew rigged a copper line on the inside of the ring that was perforated that we could pump CO2 gas through and backlight with LED lights. So then that we could shoot at a higher frame rate, but because it's motion control, it's moving the exact same rotation and track time on camera that the motion control shot was. And so by combining those two passes, we get the effect of the ring falling away and the plasma that from the rocket nozzles igniting inside that ring and giving us that beautiful burst of flame. And I wish I had that shot up. I know it looks great to talk about things you can't see. But what I love about that shot is it actually combines all of the techniques that we used in First Man. We've got a miniature in the foreground, a practical, real object, the rings falling away. Then in the background, we've got a digital Earth and digital space image. And what I think that does is it shows that we can combine these two different techniques and get compelling images. It's not either one or the other, but it's really applying both to their best ability to get what we need to see and sell the shot. We then move on to the Saturn third stage. This is the part of the rocket that had a shroud in the front that held the lunar module and also attached the Apollo command service module to it. So again, we started with a digital model and took that digital model and separated it into its base components. And then we 3D printed parts, CNC cut parts, laser cut parts, et cetera, et cetera. But this particular ship, the lunar module in particular, we added individual panels over the 3D printed pieces where we would heat them up, distort them, and then hand punch the rivets into the corners. Again, it's to give it that handmade feel that it had been fabricated by Grumman engineers and not, you know, a 3D printer working on its own at night. We also added layers and layers of different foils, black wrap, it works really well, gold foil and copper to simulate the heat shields that were added to the ships. And this all mounted inside the that third stage rocket. And we did have some drawings to work from, in our case, from NASA. And we followed them really well. And if you notice it, the lunar module fits really tightly inside this little shroud. But we want to make sure it fit as accurate as we can. Anyway, but we wanted to make sure it'd be as accurate as possible. There were 14 different colored anodized metal panels, or colors used on the metal panels on this particular mission. And we found a color guide for that. So we tried to duplicate that as much as possible to make sure that we were accurate. And this model also features the tiny plaque on the landing gear leg that was signed and dedicated by the astronauts when they got there. We made a tiny 6-scale version of that too. In addition to the Saturn third stage and the lunar module, we of course had to make the Apollo command service module. Same technique, start with a 3D model, divide it into pieces, vacuum form plastic, 3D printed parts, laser cut, and then lots and lots of individual metal panels and foil panels added to give it that texture. These models could actually couple together. We had different mounting points built into them so that we could mount them to our model mover, either so they could be stationary or rotated. One other thing we did, of course, was we added the aluminum surface to the command module. It's very highly reflective, and it's in individual strips. It's not just sprayed on, and that gave it that sort of distinctive shiny surface. And we shot this in 2 different guises. We either shot on a stage completely in black velvet on our model mover, where they would be adding space in post, or we took it over to the LED stage and actually set it up and shot it for several shots where we took advantage of the LED screen behind it, but also the LED screen had a remote controlled key light. So whenever on the LED screen you might be flying through space and the sun was supposed to be, let's say, to the left in the image, the key light itself would correspond to where the sun was supposed to be. And as we rotated the LED screen imagery, the key light would move to the corresponding correct point so that the sun was always in the right spot when we were looking at the image on the LED screen. And of course, all that shiny aluminum tape that we put on top of the command module paid off because we got all sorts of great reflections, and the gold foil on the lunar module has its own reflectability. And this is something that you get when you build something and you put it in front of a camera and you shoot it with a film camera, by the way, is all this sort of real reflective and texture quality that is not impossible, but it's harder to duplicate in CG because it requires some forethought and thinking about doing that. But by building these models, it all sort of came naturally. So this is what Damien was after, was this sort of naturalistic feel to the visual effects. A little bit about motion control. So we have a track, and on the track we have a crane that's controlled with, in this case we're using stepper motors to control our boom and swing, and then we have a pan tilt roll head on the end of the crane, and then the camera itself. So those are all controlled with stepper motors. We can program the speed of the camera, and we often shoot at lower frame rates so that we can maintain depth of field by just extending our exposures. And then at the other end of the track, we have our model mover, which has the, let's see, the roll and pan and yaw axis. Wait a minute, that is pan. Roll, tilt, and yaw axis. And we would set the model on top of that post. And then on the right, you can see it's sort of a typical shot where we've got the model on the model mover and then the motion control system lining up to it. Oftentimes, depending on the shot, we either use the model mover to move the model, or if we needed to simulate the motion of the ship, we might actually just dolly in on it and let the ship be stationary. For this show, by the way, no green screens whatsoever were ever used on First Man. We shot all against, in our case, black velvet. We would shoot a second overlit pass to sort of act as a roto guide and give that to the visual effects company to then take out the rig in the background and add the stars. But at this point, rotoing and other techniques allow us to avoid green screens if possible. and try to get almost all on camera as much as we can. So this is the ballet bit. We have this shroud. The very strong man there is working on it. This shroud, in addition to the camera having motion control, we also equip the doors of this shroud with rods and stepper motors so we can open it up and close it to allow us to reveal the lunar module inside. And here we've mounted the lunar module on a deck. We've crammed our camera on the left-hand frame. We've crammed our camera in the gap between the shroud and the lunar module. And the middle frame, we've actually backed our command module up to it. So this is a case where we're actually going to dolly the command module away. And then on the outside of the shroud, which we'll never see on camera, you'll notice the rods, and those are going to small linear tracks that have stepper-driven linear movers on them. And that's how we open the shroud. Once we were done pulling the command module out, we have to turn around and grab the lunar module. In that case, what we did was we actually mounted the camera and the lunar module both to the model mover and used the model mover, in this case, as our camera crane to pull out the lunar module. So this is, again, a typical shot for shooting miniatures. The graphite camera's in place. We've got our bounce light. We actually did something we thought was kind of fun. Since we have that reflective surface on the Apollo module, we actually took a Sharps projector and projected the Earth on it once in a while to actually be the reflection and let the black on the other side. So it actually simulated. You can't make it out, but you know it's there because the colors are correct. So that was kind of a cool sort of in-camera thing we did. Let's see. So that covers miniatures. Should we go on and show the?
Yeah, we put together the reel that we gave the Academy. That essentially was us asking them to nominate us for an Academy Award. So we'd like to show you that because it demonstrates the before and the afters with the wires and without the wires, and with the rigs and without the rigs. So.
And it covers all of the effects. It covers the practical effects, the LED screen, the miniatures, also some of the expansion work that I described for the footage. So without further ado, here's a before and after demonstration of the visual effects from First Man. So, a couple of things I'd like to point out that I wasn't there when it happened, but JD knows about it. One big thing, this movie was shot, if you didn't know, on 3 different size film formats. The close-ups, the sort of intimate scenes between actors were shot on 16 millimeter. The typical shots at NASA and our space stuff, the launches and everything else was shot on 35. But then once we get to the moon, inside the capsule is 35. But as soon as they go outside that door and they get onto the moon surface, it switches to IMAX. And this was something that Damien wanted to do, to use the film format to change the emotional point that he was trying to get across. And that switching to IMAX really made an amazing impact in terms of like feeling the sort of isolation and vastness of the moon. But you want to tell what happened in Atlanta on the moon?
On the moon, yeah. We were filming at a rock quarry that had a gray texture soil that closely matched the moon, and we were there. We had one great night. Second night got really cold, and our third night there, it actually snowed on the moon. So we had to stop production and let the snow melt and clean up the moon and go back to work the next day. So yeah, it was interesting. But thank you guys very, very much. It was an honor to be able to come up here and speak in front of you.
Thanks.
Thank you.
You want to ask? Oh,
Sure, yeah.
questions, anyone, that we can answer? Yeah, it's interesting because space has been good to me, I guess. So I worked on Interstellar also, and I worked on First Man. Another comment about Damien, and I don't know, I hope you have the same opinion. He's a great director in terms of he directs you. He actually has a plan. He actually has something laid out. He had a book, 300-page binder that he put
Day
together
one.
of reference on every scene and every shot that he wanted to put in this movie. He was very meticulous in terms of trying to be as authentic as possible and trying to keep the historical accuracy, and I'll give you an example. In the scene with the X-15, when Ryan as Neil Armstrong is doing the test, we cut quickly to his a pad on his thigh where he's writing notes. And Josh Singer, the screenwriter of the film, on that particular flight, on that particular test, found out what Neil Armstrong had written on that pad. And we shot it like 5 times of him writing exactly what he was supposed to be writing down. You can't read it in the movie. You don't know what he said.
But it's there.
But it's there, and it's authentic. So that's the kind of level of authenticity that Damien was trying to get us to portray and trying to get that emotion across. And so every day we went in, we always tried to do the best we could to get that feeling out there. And for me, I foolishly thought I could be an aerospace engineer at one time in my life, so I actually studied that. And the opportunity to work on this movie and sort of honor the men and women who made all that effort back in the 60s to put this sort of big achievement together was another honor. And Neil's son and his family came through and checked out the models and looked at what we were doing, and we kind of got a sense that I think he would have been proud of what we did. So I just wanted to say I really respected those men and women that did what they did, and it was great. It was fun. It was great to be on that project doing that.
Yeah, watching that kind of brought back some headaches.
Yeah.
That was,
Yeah.
That was a lot of work on
Yeah.
that film. Yeah.
Yeah, and now it seems fun, but like in the moment, you're always challenged.
Yeah.
And that's the thing about visual effects. We don't get to do the same thing twice. It's always something different. Each assignment's got its own challenges, but hopefully we get through it. So yes, anybody?
Hi, Cliff Baldridge here. Incredible work. On that video wall, was that Unreal Engine or Unity, or was it a special software?
It was not the real engine, and I do not remember the name. I I know. We need Paul up here for that.
Yeah.
I apologize.
You got it. I'll figure it out. Thanks.
Yeah.
First of all, congratulations on
Thanks.
that. It was a great job. Second of all, from Atlanta, so I'm just curious where the stage was in Atlanta that you shot on.
We filmed this at the new Tyler Perry film studio.
Down on the south side?
Yes.
Yeah.
Yep. Yeah, and the moon was in Cummings, Georgia.
Okay,
Yeah.
all right. And my son also wanted to be an aerospace engineer. He's graduating, God willing, in November, like next month. He's a mechanical engineer at Georgia Tech. But anyway, one of the things that he had the pleasure of doing was setting up some programming at a machine shop there, and they ran a tool right into the chucks of a $150,000 mill at high speed.
I was going to ask for your kid's number. Now
Yeah, no, he's really good.
I want him running
He
my
is
machines.
really, really good. Actually, it's a long story. But I was just curious, with all the stuff that's moving in these shots, do you guys have predictive software that lets you know about collisions, or do you run stuff in slow motion and somebody's got a big red button?
Yep.
Or I was just curious how you work that out, because keeping track of everything could be really
Yeah,
complicated.
none of our stuff is like collaborative, you know, as far as the robotics go. It's all closed loop motion control. So you're sending a signal and it's going to a position. We do model as much as we can in a 3D environment, and that model is in the computer, so you can anticipate things ahead of time. You do run into collisions every now and again, as somebody will put a C-stand up on top of the motion base that the operator doesn't see. It'll go and whack something. It does happen. But no, it's a time-grueling process of going slower and just speed up a little faster, and make sure everything's out of the way.
Yeah,
Yeah.
great.
I mean,
Thanks.
in our case with the miniatures, we were shooting at a slower frame rate, so we didn't have as much issue in terms of collision or crashes. But yeah, as you increase and actually go into high-speed mode, sometimes it gets more dicey. So you generally rehearse at half frame rates, and then you go up from there.
Yeah, we had one of the first mocap rigs at Turner Studios, and figuring that part out and the slow speed part was part of the learning process. So,
Yeah.
thank you.
Thank you.
Congratulations on your awards.
Thanks.
And thank you for presenting here today.
Absolutely.
I have a question. I always look at things like for the finer details. In the close-up scenes of Ryan Gosling in the X-15 and in the space capsule, the reflections off of his helmet, were those projected or reflections off the LED screen or rotoscoped in after the fact, or how did you achieve that?
Those were reflections off of the LED screen. Yeah, almost everything.
Yeah.
Everything on Ryan for sure was the reflection off of the LED wall.
And in addition to the wall, there was another wild screen that could be put in with a crane that could play. So if you were, let's say, here looking that direction, and you had a window and you would have had a reflection of space or something coming out this way, we could project the corresponding spherical part of the image on that screen too, so that if they turn their heads or whatever, they always were surrounded by reflections of the environment.
Yeah, it was like a wild monitor. It's about as big as our monitor
Yeah,
here.
about that size on a
Yeah.
crane.
Yeah.
Excellent work.
Yeah, thanks.
Thank you.
Hi, Andy Rayner. Excellent work. Absolutely love it, gents. Thank you. Quick question about the LED wall. That seems quite a novel way of doing that, and obviously very interactive. Did you have any issues with aliasing at any points in terms of the camera and the resolution versus the actual resolution of the wall, or did that all work seamlessly?
We did in the beginning. There was about a 2-week period where we just had to play and work with the wall to iron all those issues out. We shot on film, so there was a big issue with the syncing of the flicker of the LEDs. That got figured out in about 2-3 days, and then it was on to the motion, the jitter from the images playing on the wall, and then the engineers that were running it came up with a filter to sync the shake of the image with the frame of the film cameras. So we actually were able to use the film camera as almost a crutch to eliminate a lot of those issues.
Wow,
Yeah.
thank you.
Yeah.
You mentioned all the in-camera effects, and of course Christopher Nolan is you worked with and presently shooting with all the in-camera effects. You want to comment on, is that going forward? Do you see that happening more and more, and directors taking cues from things like you've done and Nolan's doing, and versus CGI?
Yeah, I think they're coming to terms that that you can still do things practically. You can still put something out there for real. You still get a lot of mileage out of that in terms of what we call the happy accidents. You know, the reflections in Ryan's eyes that no one would have thought to put in there. When we were shooting it was about I'm going to say it was 11 minutes, more like 8 minutes, but it's the shot of, or the scene of them going from the Apollo module down to the surface of the moon was shot as one continuous take, and in front of the LED screen on the motion base. And Ryan Gosling and Corey Stoll, who was playing Buzz Aldrin, were both inside the capsule, and there was a cameraman inside the capsule, and there were two cameramen on the outside of the capsule shooting this whole scene. And because they had the LED screen there, Ryan would be doing his action, then he'd look out the window and he'd be looking at the image. And this cued the cameraman to look out the window also. So if that had been a green screen, no one would have thought to look out there, no one would have had that interaction going on, and it sort of created a very naturalistic feel to the shooting. So I think it's really a matter of combining these techniques, and I want to emphasize here, there's a lot of in-camera work, there's a lot of practical work, and there's a lot of CG also on top of that work to extend the image or to finish out. You know, sometimes the LED screen, we'd see off the edge of it.
Yeah.
So in post, we would need to extend that space to composite that in to complete the shot. So it does have its merits. It can work hand in hand with CG. The big difference is between Nolan and Damien and directors like that is they'll make up their minds. They'll actually decide this is what I want to do, and they'll do it. And that's the biggest thing, because all of the imagery that was used on the LED screen was front-end loaded. We had to shoot that beforehand, or DNEG had to create the star fields and the Earth before we started filming, and we needed to know where we were looking when we were shooting all of that. So all of that material had to be created up front, and a decision made to use it in order to get the benefits of doing it all in camera. So I think I'm gonna wrap up my moment, but someone asked, like, well, is it more expensive to do it this way than to do it in green screens? And the supervisor, the VFX producer on this show said, no, it was less expensive to actually do all this up front and shoot it in camera and get it as much as we could and add everything, these sort of augmented pieces in post. But it took decision making on the part of the filmmakers, and I think that's the big difference between, you know, really good filmmakers like Christopher Nolan and Damien Chazelle, people that make decisions and then have a vision and stick with it. So,
Yeah, and to add to that, I think the visual effects are fantastic, and that's why we're here. I think when you can add mechanical effects or a practical gag into it, even if it's something as, you know, if we had to knock over this podium and it wasn't there and we just knocked over a piece of wood, the wood is always going to fall, or the podium is always going to fall in a way when natural physics take over, and we can't, the human mind and even the computer can guess as best as they can as what that thing is going to do, but it will always do something odd every time. Whenever we flip a car, make an explosion, or a drop of water, whenever it splashes, it always does something organic that a computer, I mean, they're getting very close, but there's always a little detail that gets picked up. So it gives you the organicness, and then it also, doing it practically, it gives the actors and the filmmakers, everyone on set, the emotion from the gag. So I like doing them real.
and a lot of times with the CG, if we have a practical element in the shot, you know, let's say the Gemini capsule, and the Gina might be extended or added to it, having that practical object there with the correct lighting, the reflectivity and everything, it gives the CG artist something to strive for, something to gain. If they can get those two side by side and they can't tell the difference, then they know they're making something that looks real because it's compared to the real object. So it actually benefits CG artists and the filmmakers if we have something practical in the shot.
I'm not very familiar with the use of LED screens, so excuse me if this question sounds naive. the LED wall is curved in one plane and rectilinear in the other. Would there be any visual perception advantages to having the LED wall curved in both planes?
I would imagine.
Probably, yeah.
There would. There was tons of discussion as to the curve in the one direction and the flatness in the vertical plane. And a lot of it stemmed from the anamorphic lenses that they were shooting with versus non-anamorphic. I would imagine at some point having a curve, if you were filming beyond, that it would help, yeah. You couldn't, when you notice a lot when we shot under the LED wall, we would pick a point and shoot it and stay there and come back out, look out a particular window, the camera would go away and then it would look out a different window. There's not a lot of panning across the LED wall, and that was because it took time to set up each shot to compensate for that curve. So,
Thank you.
yeah, it's a
Excellent
good
work.
question, actually, and probably one that we need to think about.
And one of the things too, I mean, this is one of the first times in a while that something had been done like this with using the LED screen. There have been, in Interstellar, we used 2 projectors synced up and crossed and the keystone taken out of it to try to get our backgrounds. The LED screen, of course, it's there. It's like the modern equivalent, I guess, of a rear projection screen, but with much more intensity. But what's kind of cool about it too is you don't necessarily have to shoot into the LED screen. You can actually use it for lighting too. That other screen that we mentioned, if we weren't looking at it, sometimes the DPs would actually use it to just put the images up so they'd get the correct lighting on the X15 that it should have had from that direction. So there's a lot more uses for that LED technology than we thought we could do, but more so in terms of lighting in addition to just the image that we're photographing. Cool. Well, thank you very much.
Yeah, thank you again.